I'd like to get started. I'm sure people will join in a little bit. This is a workshop on Spatial Vis, which is an app that we've developed that is suitable for remote instruction, and it's for spatial visualization skills and sketching related to CAD and drafting. And to give you a little background about myself, my name is Lelli Einde, and I am president and co-founder of eGrove Education, but this is a startup out of UC San Diego. So my background, I'm a professor of structural engineering, and I teach all sorts of design and also beginning drafting class for our freshmen. And my colleague and I, he's a mechanical engineer at UCSD. We met several years ago, discovered that a lot of our students are lacking in 3D spatial awareness and different skills that are very needed for success in the engineering field and many STEM fields. And so we started to develop this app that works on touchscreens. So I was going to present it a little bit to you and give you a little bit of background, show you the app and the content that's available within the app, let you guys play with it, and then after we're playing with it for a while, we'll come back and I'll talk a little bit about some best practices for how to implement it in classrooms, because I also use the app in my own class to teach CAD and spatial skills, and then end with sort of a little bit of information of some of the other resources that we have available for teachers, and also how for you to get a free teacher demo account, which gives you access to the entire app and stuff. So this is a really informal workshop. So I ask that if you have a question, you unmute and you just blurt it out so that we can get the questions answered. And I look forward to the next 45 minutes to an hour that we have together. So to give you a little bit of a background, I already said a little bit, eGrove Education is a startup out of UC San Diego. We've been around for a couple of years, but we're only just starting to get, so we've been targeting mostly four-year institutions, first-year engineering programs and introduction to CAD classes, but there's a huge interest now in the K through 12, which is where which is where I feel that we should be teaching these skills prior to students going into college, or if they're in community colleges and want to get a technical degree and get a job being a drafter or something like that. So we developed this touchscreen based app, and I'll go over some of the features about it, but it has an automatic grading algorithm that allows it to be very suitable for remote instruction, and it gives feedback and some meaningful hints to the students as if a teacher is looking over their shoulder, giving them some feedback on their sketches. So what's really nice about this is we're teaching hand sketching, but we're also, I guess normally spatial visualization skills are taught through multiple choice questions, which is not as we feel the benefit of actually sketching improves your spatial skills. So I'll talk a little bit about the importance of spatial visualization and sketching. I know that most of you guys already understand this, so I'll gloss through it pretty quickly. But we're all familiar with this standard spatial visualization mental rotation test. You take an object and you rotate it a certain amount, and then can you understand how that was rotated and do the same thing for another object? So this comes from a standardized Purdue spatial visualization test. And it really assesses the importance of being able to mentally rotate images, 2D and 3D images in your mind. And so if you're teaching pre-engineering or beginning CAD classes, many students come in there with this skill already. They've played a lot of video games. They can go from 2D to 3D. They don't seem to have a problem, but many students also struggle with this, and it's a learnable skill. It just isn't really currently taught in our curriculum, or at least the traditional curriculum. So it has been shown for a number of years that for underrepresented minorities and women, that spatial visualizations are skills that might help promote, or a lack of these skills might deter girls from pursuing math and science careers. But as I said, built on this longitudinal study, we have seen that spatial visualization is a learnable skill, and sketching actually enhances your spatial skills. And so this has been shown with different research studies, but you know that sketching is important when you're generating concepts and you're doing brainstorming with teams. It's a way to communicate your designs, and if you want to get an idea across very quickly, you don't often have time to jump to a computer and create your nice rendering in CAD. The first step often is sketching your ideas before heading into the computer. So we believe spatial visualization and sketching are important. So the challenges that we faced in teaching this, obviously, there's certain learning outcomes that people have to teach, and often this is a skill that's, we already have a packed curriculum and there's not much room to add teaching sketching and spatial skills. Like I mentioned before, the students that you get come with a wide variety of spatial skills, so some need more practice and time than others. As you know, as an instructor, grading hand sketches takes a long time. And especially with remote instruction, getting students to do a hand sketch, take a picture of it, send it to you so you can grade it and send it back is quite tedious. And so there's definitely value, and we need tools to support this type of remote instruction. So the solution to all of this that I want to present to you is the Spatial Vis app. And I'll show you a little video if you haven't seen it yet. This just kind of let me see if I can get to it. Are you able to see this? I hope. So this is just, kind of summarizing, the importance of spatial skills in supporting students' success in STEM majors, and that it's a learnable skill. And then it introduces the Spatial Vis app. It's available on iOS devices, phones and tablets, and Android devices, as well as Chromebooks. And as I said, we have an automatic grading algorithm that gives feedback, personalized feedback, tells you what's correct, what's incorrect, encourages you to be persistent. We have a star reward system. We have different kinds of lessons, teaching orthographic and isometrics, teaching how to go from 2D to 3D and vice versa, how to rotate objects about different axes. So this is just sort of an overview video. Let's see if I can get back to, there we go. So just to summarize, the sketching is done on touchscreens. It is not a web-based program right now. We think the act of sketching using a stylus or something mimics the pencil and paper. But if you have a situation where the technology is not available, where there's not a touchscreen available, we can use like an Android emulator on a computer and use a mouse. But we don't feel that that's the exact experience, but it's doable. We do have an automatic grading algorithm, and it provides instantaneous feedback, and we're trying to add more personalized hints. Like first it tells you what percentage of your lines are correct or incorrect, so you can see how close you are to the solution. But we are adding some more hints, like if you're missing a line, sometimes, and I can show you some examples of this in subsequent slides, you might be missing one line, but it's not really easy to find. And so you think you're correct and you keep resubmitting the same drawing, but so if you get a clue or some kind of hint that you're missing a line, you can be more sort of diligent about looking for that. We have a star reward system, this gamification. It's to increase persistence. So a long time ago, we tested our students coming in about their spatial skills, and the low performing students, we had them try the app. And we found at the end that half of the students, when they took the post test, increased tremendously, and half didn't improve at all. And we were wondering what's going on, why aren't they improving? And when we went in to look at the sketches and what the students were actually doing within the app, we found the students that were not improving, they were just drawing like one little line and then peeking at the solution. They were not even trying to draw, and they were not trying to be persistent and learn. And a little bit about, you have to struggle a little bit in order to learn. They were giving up right away. So we tried to encourage persistence by having this star reward system. And I'm going to talk a little bit more about that when we get to best practices of how to implement this in the classroom to encourage engagement and persistence. And we'll get to that later. What's nice about the app is that it can be done either in class or at home. So if most of you will be in remote, but if any of you have a hybrid situation, you can also do it in class. And we do have a teacher interface that provides data analytics for you to see how your students are doing. Just to kind of go over the grading algorithm, this is just an example. Here is the assignment in the app. What's given to you is the orthographic projections, and you need to produce the isometric. And you can see, if you take a look at it, that I made a mistake here. And so when I hit submit, this is what the grading algorithm pops up. It says, okay, you have 12% incorrect lines and you're missing some lines. So something is wrong here, and it allows me to go back and look. I can retry. We encourage students to retry as many times as they'd like. That's the whole persistence factor, and typically if they keep practicing, they're going to get better at it. You can take a hint, and this is what a hint shows. It basically showed me that something is correct over here, but that this is not correct. These lines that I drew here are not correct. So when I take a look at that, I kind of will look back at the assignment and see that I was wrong in terms of the number of cubes high that this object needs to be. So if I take a peek, instead it shows me my incorrect lines, and it shows me the missing lines as well. So this is the feedback right now with the grading algorithm, but if you take a hint, you lose 1 star. So you can retry as many times as you'd like and get 3 stars if you finally get the answer right. But if you take a hint, you lose a star. If you take a peek, you lose 2 stars. And so we can identify students that are hinting or peeking often by the number of average stars that they're earning on these assignments. As I mentioned, we like to provide mini hints where we actually give them some hints that won't make them lose any stars by taking a hint or a peek. So there's no point penalty. And it's based on what a student drew. So we don't really show them specific which lines are correct or not correct, but we kind of hint to where the error might be. So some examples, well, we've already shown that, but could be this one where you may be missing a line. And if those of you are good at making these drawings, you can see that we're missing this line right here that changes the plane right here. And so it tells you you're missing a line. And so a student can go look very closely and try to find what's missing. This is an example where you might have an extra line. And so you can see right here, this is all the same plane. And so we don't need this little line right here to separate this plane. So these types of additional hints are in the works, and we hope to have them in our next release, which will be in the next few weeks. But this is the type of feedback. For example, another one that we're interested in doing is if they're doing orthographic projections and they have a small mistake maybe in the top view, that we could basically give them a hint and say, you might want to look at your top view, so that they don't get frustrated trying to find where their error is. So that's just the basic introduction to the app. Now it's your turn to get in there and play, and I will plug my phone in and show you. If you joined late, you can download the Spatial Vis app right now. If you go to the Apple or Google Play Store and search for Spatial Vis with an S, you can download it. And then when you open up the app, right now, we're going to give you sort of the free demo mode, but at the end of the class or this workshop, I will give you access to how you can obtain the full access to the app. In the free demo mode, what you'll do is click in this button, not for course credit, because you haven't created an account yet. So if you click not for course credit, then it will open it up to you, and you will have access to all the assignments, but the grading access is only available for the first 5 assignments. But this will be enough to get you to get started playing around with the different activities. So go ahead, and you're welcome to stop me. I don't know where everyone is in terms of the download. I hope everyone is able to do that. And this just kind of gives you an overview of the different lessons. I'm going to go through and talk about the different material that's there, and then give you some time to start playing around with the app. The lesson introduction really just, so I'll go into all of these in detail. So there's a lesson introduction that really just gets you to acclimated with the grading algorithm, how to zoom in, how to count the number of squares, you know, and just very basic introduction in the user interface. So I encourage you guys to try to do all of that. And we'll have more time later. I'm just going to go through the different lessons. We scaffold, so we start pretty simple. Our first lesson is 2D rotations. So basically, it's students are given an object they're given a pivot point that they need to rotate, and they're given the angle by which, whether it's counterclockwise or clockwise, that they need to rotate the object. And what they're expected to do is draw the final resting point. So if it says to draw a 90-degree rotation, they would draw this dashed line, which is the final answer, kind of a thing. And I'll get into this later when I plug my phone in. The next lesson is called Ortho Cubes. And it really gives you sort of a plan view. So it gives you something here on the left. A plan view has some sort of dots to help you guide you building or drawing the isometric. But then what these numbers represent is the number of cubes high that you need to draw. So this is a one cube high, and these are 2 cubes high. So when you draw the final isometric, that's what you end up drawing. So these are really teaching you how to go from 2D to 3D space without getting into orthographics and isometrics just yet. But then we get into what we call Ortho Cubes, and this is where the isometric is given to you, and we teach the students how to draw the third angle projection, which is the top, front, and right side views. I'll show you when I get into it, but we scaffold and show them about miter lines, and we even get into how to do hidden lines. So if they were to do like a back view of this, on the back they would see a hidden line. So we get into some of that in this lesson. Lesson 4 is the opposite. It gives you the orthographic projections and asks you to create the isometric, the corresponding isometric. So you can see we're going back and forth between 2D to 3D to get them to improve their visualization skills. And then we have a lesson that's primarily dedicated to slopes and curves. So we teach them a little bit about how to draw curved surfaces, slope surfaces, either going from the orthographic projection to the isometric or vice versa. And hidden lines are incorporated here. We do have lesson 6, which is considered flat patterns. So it's really unfolding nets and getting students to visualize how that unfolds. And I can show you some examples of that as we get into the app. And then we have 2 lessons related to rotations of mental rotations within your mind about an axis. So lesson 7 is rotating a 3D object about one axis. And we show them, that if you're rotating about the z-axis in the positive counterclockwise direction, we can also actually show you just different ways. So in this one, they only rotate about one axis, but in the next lesson, they first rotate about the blue direction and axis, and then they have to rotate about the red. And so in this particular one, it's one of our hardest lessons. Students are supposed to visualize the first rotation, then visualize the second rotation, and submit the final resting position. So this kind of walks you through the 2 mental rotations that have to happen, but this is the final submitted sketch in the bottom right corner. And then our final lesson is kind of like a capstone. If you know what a soma cube is, it's like has 7 pieces, like 3D Tetris style pieces that fit together to form a cube. And with these 7 pieces, there's over 230 something solutions to this cube. So we provide students with 1, 2, or 3 pieces, and they have to mentally rotate them and solve the soma cube. So this one's kind of a fun capstone type lesson at the very end. Okay, so I guess with that, I'm going to stop sharing this and stop and ask if there's any questions before if you're playing around. I'm gonna just get my phone on the screen and play around and show things. So I'm opening it up to questions if anyone has any right now.
Yes, it asks for an email and a password. What do I use for that?
Okay. So if you can see the screen, I will bring up the Spatial Vis app. And you can see my progress. I've done demos with this, so I've had relative progress in different assignments and things like that. But again, this is the intro app. I was just testing the grading algorithm, but one of the things in the upper right-hand corner, you see those 3 parallel lines. If you press that, you can see all the activities that are in this particular app lesson, and you can jump around. So, and you can see with a check mark the ones that I've already completed. So I'll go to one that I haven't done. And this one is asking you to, is teaching all about panning. Oopsies, that wasn't panning. I didn't use two fingers. Panning and zooming. So being able to, and you can see a stray mark here, so I'll erase that. And being able to draw the shape accurately. So this was just teaching about panning and zooming, and then you could submit it and get your results. Great job. So I encourage you guys to do the introduction. The 2D rotations, I'll jump to maybe a different one that I haven't done. What I want you to notice is in most of the lessons, there are around 27 to 35 assignments, and they get progressively more challenging. The last 3 assignments in every module right now, so in this case, it's 29, 30, and 31, they are called test questions. And what we do is we back it down to a medium level difficulty, and it becomes an assessment. And we no longer allow them to take a hint or peek. They basically have to keep drawing this until they get the right answer. And so we do this so that students we can just do a quick check to see that they're not relying on the hint and peek, and that they're actually learning the skills that are, or the outcomes for this particular module. So in this case, you can see a number of different activities. I'll pick one that I haven't done. So here's one where we want to rotate this object negative 90 degrees. And so you maintain the yellow dot, and I will draw what I think the final solution should look like, and hit submit. And I get a great job. So here's another one. I can, we like to teach that a 270 degree rotation is the same as a negative 90 degree rotation. And so I'm going to draw a mistake if I can. Let's see, I'll go too far. So if you can see, I kind of went a little bit too far. I'm pretty off. And if I submit it, it tells me that I have quite a bit incorrect. So I can retry, which is what we encourage students to do, but I could also take a hint, and the hint shows me that some of my lines are correct, but these other ones way out there are not correct. So it gets me to think, okay, maybe I'm not really in the right location, so I can continue drawing. If I submit it again and hit the and check peek, it now gives me the correct solution. All these ones in red are incorrectly drawn. The green ones are correct, and the blue is what's missing. So I can actually draw the full solution. But at this point, if I continue to make my correction on here, you will see that I will end up with 1 star because I took a hint and a peek. So let me submit that, and I get great job, but I only got 1 star. One of the things I wanted to mention, we don't have a snap to grid feature because we still want students to learn to be somewhat precise in their sketching, but we have what we call a straight line feature. So let's say I'm trying to draw a line, this way. I can hold it down, and when I hold it down and release, it straightens up the line for me. So when you release, you can go a couple of times, whatever. And then when I release, it will kind of straighten up. That one was a little bit too far out. But so you can practice that straight line feature where you hold on to it, and then if you release it, you have to hold it down for a few seconds in one position, and you'll get a straight line. So I just wanted to mention that as a feature. So that's 2D rotations. I can show you the Ortho Cubes again, where you get into, here's a good one. This shows you the yellow dot and the right dot, and it's 1 cube high. I can zoom in if I want to be more accurate. And then it's 1 cube high in the beginning, but it's 2 cubes high in the back, and it's only 1 across. So, oops. So we can see if I'm off the lines too much, I'll submit it. And you can see the grading algorithm was fine. So my sloppiness was okay in that case. And we have the grading algorithm, it's got sort of a buffer, and we've adjusted the parameters so it's not too strict, but it's still strict enough. So that's ISO cubes. Any questions before I continue through some of these? I know you're playing on it with it on your own. Kind of hard with the whole Zoom thing to get a lot of active engagement. You know, we all struggle with this. I definitely had trouble in the spring when I was teaching my CAD class and trying to get students to answer questions. So I'll go to the next one, which is lesson 3, which is Ortho Cubes. Again, if you go back to the beginning, it can give you an introduction. It shows you that we're trying to get them to look at the front, top, and right side views. And then when it teaches a little bit about the miter line, just to teach them correct placement and how things line up. And then it does teach about hidden lines. So if we're looking at the right side view, we would have a hidden line. Later on in the exercise, you'll see when we get into hidden lines, we do have an exercise where we teach them how to do the dots, which is basically, you know, touching the 2 lines and then 1 small dash in between. And that just helps them with the hidden lines so they don't get frustrated if their dots are not correct. So we try to encourage them to do the dash lines in this format so that it gets graded properly. So you can look at, we scaffold and it gets much harder, but let's, you know, maybe pick one like 17. And it asks you to draw the front, top, and right side views. There's no hidden lines. I'm just going to submit it, and I'm going to take a peek, and then you can see what the final solution would be like. I don't normally peek, but if you need to see the final solution, that's what it looks like. And you can just see that the assignments get progressively harder. So where we have some that actually have hidden lines in them, some unusual shapes. And then again, like I said, the last 3 test questions, in this case, 34, 35, and 36, they're test questions. They go back to a medium level difficulty, and you are not allowed to take a hint or peek. So if you guys clicked on some of these, you would, it says test question, no hints or peeks, but in your case, you won't have grading enabled because you're in the demo mode, which we'll correct that once you finish this workshop. I'll show you how to get full access. So the 2D to 3D, as I mentioned, is now giving you the orthographic projections and asking you to draw the final isometrics. So we could zoom in and do this. Oops. And something like this. And great job. Again, like I said, slopes and curves has a number of different, starts with slopes, teaching you how to draw the slopes. And again, we go from isometric and draw the orthographic projections, and then vice versa. And then it introduces curved surfaces and gives you a few examples of those. The flat patterns are tricky. They are trying to get you to unfold nets and shapes and then draw where these lines end up. So you have to kind of rotate and flatten these objects and then draw where these lines end up. You also have these options where if it's a green line, it folds in one direction. If it's a red line, it folds in another direction, and you need to draw what the final isometric would look like. So this one gets a little bit complicated. And you can see that it's trying to unfold all these nets, but then you have to draw what the graphics would look like once it unravels and stuff. So I would try these. These are good combining some of the rotations and then again, like I said, the rotations about the 1 and 2 axes. I'm going to jump to 2 axes, lesson 8 right away, because it's one of the more complicated ones, but you can see some, and try to first rotate this object about the yellow dot. And in this case, around the blue axis, which is positive 90, about the y-axis first, and then you have to do 180. So if I submit the final answer, you can see what the final solution would look like. And then I had shown you assemblies as well. So assemblies, I hope you're playing with it right now and just listening to me in the background, but you can have a bunch of different. So for example, here are 3 different shapes that you need to finish the puzzle piece, basically. So it's not only about rotating, but seeing how they all fit together. This gets quite tricky. This is one of the ones where we suggest, we have some 3D printed STL files that you can print and have students in class take these shapes and actually manipulate them and try to finish the Soma cube, and then they can actually sketch what their solution was. Or, you know, you can buy Soma cubes on Amazon, and students can try to do this. So the hands-on manipulatives are always very good to scaffold and to get them into doing it before they do it all in their mind, because it gets quite tricky and challenging. So that's pretty much the app. I'll let you guys play with it for a little bit more, or open it up again for some questions. So if we don't have any other questions, you can continue playing. I'm going to just move on to sort of best practices for implementation. I kind of mentioned it before. So I've used this in my classroom. We've been in other classrooms at other universities and done all sorts of trials. And so these best practices come from just being in the classroom and seeing how the learning has, the learning gains. And so what we've done is we've done tests where we've administered a pre-spatial visualization test. It's the Purdue Spatial Visualization Test. It's a 30-question multiple choice test that you have to finish in 20 minutes. So it's a time test, and it's like that slide I had at the beginning of this lecture where you have to rotate an object similar to how another object was rotated. So we give a pre-test, and then we do the app, and then we do the post-test. We encourage you to, if you would like to see what the learning games are in terms of spatial skills, you can implement the PSVT, and we can show you how to do that. It's available on learning management systems. We do recommend that the students do the entire introduction module, but for the remaining modules, the way I implement it, and other schools have done it and it works really well, is I assign the odd assignments, and then I assign the last 3 test questions. So if there are 33 assignments, they do 1, 3, 5, 7, blah, 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 and then they do 31, 32, and 33, the last test questions. And I tell my students, if you do all of the odd assignments in the last 3 test questions in the entire app, the total number of stars that you can receive, if you do it perfectly, is like 452 or something like that. So I tell them, I want you to get a perfect score, and you'll get full credit on this assignment, on using the app. But if you have to take a hint or peek, that's okay. I don't mind. I want you, when you need to take a hint and peek, you can do that. You just have to make up the stars by doing an additional even assignment. So students are encouraged to try to persist and do their best, but if they need to take a hint or peek, they can make up the points and still get full marks if they do an extra assignment or 2. So that's one way that I do it. I do recommend that if you are hybrid, that we have on our website some lectures that you can use, and some hands-on activities and some worksheets. So I do think that the manipulatives are very good. We use these snap cubes. This is not it, but that let the students build the shapes and then rotate objects, and or at least rotate it to see what the different views are and be able to draw things. So those are always good. In remote instruction, it's not as easy unless you can get them some snap cubes or some other things to help them when they're at home. But the nice thing about this app is that it can be assigned as homework, and it can be used very easily for remote instruction. The grading of the sketches is immediate, so students are getting feedback right away. They don't have to scan in their sketches and send it to you and wait for you to give them some feedback. I did want to say, in order to promote persistence, I told you about students earning their minimum number of stars, but I also think that the practice makes perfect. And so I encourage my students that they can, if they get the minimum 452 stars, they get full marks. But if they do more of the app, if they do as many problems as they can, and they get perfect scores, or if they get close to perfect scores. If they get above, let's say 600 stars, then they get maybe 1% extra credit in the course. It's up to you to decide what the incentive might be. If they get over 700 stars, then they get 2% extra credit. And if they get over 800 stars, then they get maybe 3% extra credit. And I think the perfect number of stars is like 852 or something like that. So I have found that my students, even though they're college students, and I didn't think they would care so much about this, they're all over getting, first of all, they're competitive and they want to get the most stars they can, but then they're all over getting extra credit. And so I found that many of my students did the entire app, and I just think the more you do, the better. So that was one way that we promoted persistence. And when classes adopted this sort of approach to encourage students to persist and get as many stars as they can, we saw some of the low performing students, we saw close to 80% of them moving out of the at-risk category and passing the post-test and doing extremely well. So it definitely works. So I did mention that we have some teaching resources. Let me see, there was a chat. How can the instructor get access to the student scores? Okay, so I can talk to you about that. We do have a teacher interface right now where you as an instructor will log in and you have access to the performance of your students, and then you can download CSVs that you can then import to your learning management system. The CSV can show how many total stars, how many stars they earned in each assignment. It also shows percent complete of the modules, depends on what you're actually grading and how you're giving them credit for it. And so we also, we're working on improving the teaching interface where you can actually see if a student is peaking too often. So you can see their average number of stars, and if their average gets a little bit lower, it kind of red flags because they're peaking and hinting too often. You might want to have a discussion with them about how to go and or encourage them to try to persist a little bit longer and try over and over again before taking the hint and peak. So I can show you this teacher interface in a second. It is an area that we hope to improve and give more different types of CSVs that can be downloaded. And then of course in the future, direct integration with learning management systems, but we're not quite there yet. In our website at egrove.education, we have a space called For Teachers, and if you click on teaching resources, this is just showing you that for each lesson, we're building out these resources, but we have lecture material. Right now there's no audio with the lecture, so you can kind of just play the slides. But I plan on adding audio to it soon. There are, for some of the lessons, we'll be placing worksheets there. So these are worksheets that you can print up and have your students, if you're in class, you can have your students do these worksheets before getting into the app. Some of them are multiple choice or matching. Some of them are actual hand sketching on paper. And then we also have those hands-on activities, those manipulatives. So we have for most of the lessons, and we continue to improve those resources as well. So here's an example of one of my favorite hands-on activities. It's kind of a glass box approach. So we get these plastic containers from Amazon. They're pretty cheap. These are the snap cubes that I'm talking about that are very good manipulatives. And you just need dry erase markers, some foam tape, but that's just to be able to place your object inside. So what we do is a student might build a shape, put it inside, and then they will take the dry erase markers and draw all of the views in the glass box. So they'll be able to look at the different views and draw all of them. And then when they're done and they think they've done it correctly, they take the shape out, and then they pass their box to another student. And that student looks at all the different views and tries to recreate the shape that they had built beforehand. And you can increase the number of cubes. You could say, hey, students, use 5 blocks, make it more complex, use 7 blocks. But it's a really interactive, great way for them to go from isometric to orthographic and vice versa. So this is one of my favorite hands-on activities, but it's just an example of the types that we do. Okay, so some leaving thoughts. yeah, I'll go through the leading thoughts, and then I can quickly go to our website and show you the teacher interface if you'd like to see it. So just, as I mentioned, Spatial Vis teaches freehand sketching primarily to improve spatial skills, which is very important for all sorts of STEM majors, technology and manufacturing courses. It has been shown that spatial visualization is a fundamental skill for success when learning CAD or design, but it's often challenging to fit sketching and spatial visualization into many courses. But our app trains students. You can do it remotely and work independently, so you don't have to use classroom time, and it provides automatic feedback and personalized hints when done. So this is the how you guys get a free teacher demo account. So if you go to our website, I'll keep this up here for a while, and I think this has been recorded, so you guys can come back and look at it. But the main thing is to write down this teacher demo access code. So this is, and please don't necessarily share it with a lot of people. If you have any colleagues that are interested, have them contact me, and I'll get them a different code. This one is related to this particular workshop. But you can visit our website, and then you click on the enroll sign up button. And that's where you enter your name, email address, and then a password. And so that becomes your account. And then you'll get an email in your email inbox. So make sure you click on that and verify your account. You need to do this step to confirm your account, and scroll down and click the URL, and then go log into your into the app and use your email and password that you created, and then you can enter your invite code, and then select enroll. Oh, sorry, you do that at the website, and then you download the app, and then you can log on. Once you do the invite code, you can log on, and you'll have full access to all the assignments with grading, not just the first 5. So that's all I have right now. I'm going to open it up to questions. I can get out of this I'll leave this on here for a little while in case anyone wants to do this, or you guys can look at the or you can always just contact me it's info@egrove.education, but also you can put my name, Lelli, Lelli, at egrove.education, and if you email me, I can set you up with this demo access if you didn't have time to write this down, kind of a thing. So, okay, any questions?
Hate to be the elephant in the room,
You're
but
muted right now, Dawn.
oh, sorry.
Oh, okay, go ahead. I'm sorry. Yes, I can.
Can you hear me?
Yes.
Hate to be the elephant in the room, but what is the expense to our students for this?
Well, so that's something that we can work with schools, different schools and districts. It depends on the number of students. It ranges from $10 a student down to about $5 a student, depending on the size. So yeah.
Okay. Thank you.
Mm-hmm. Good question. Anyone else?
I love this. Thank you for doing this.
Thanks. Yeah, we've been working on it. We definitely feel there's a need right now. It's, to be honest, I love using it in my classroom. Students love it. It's engaging. When I ask them where do they do the app, that it's when they're waiting for their laundry to get done. These are college students, obviously, right? But waiting for their laundry, or waiting for the bus, or on the bus. Some have said while they're sitting on the toilet. They find it fun and engaging. So, and it's great practice.
Yeah.
Yeah, cool.
So, if you have trouble accessing the free teacher account, just email me at Lelli, Lelli, at egrove.education, or info@egrove.education. Either one, we can get you some access. And if you have any further questions about the app, I'd love to have a personal call with any one of you. So just let me know.
Thank you.
You're welcome. So if there are no other questions, enjoy the rest of your conference and all the workshops, and good luck getting ready for fall.
Thank you, Lelli.
You're welcome.
Thanks.
Take care.
And your email again is what?
Lelli at egrove, EGROVE .education, the whole word education.
Thank you.
You're welcome. Take care.